And the four groups, there's one. Why the heck did it do it's not very smart, right? It's confused about these two groups because it put those together. My k-means is not working very well. At least my principal components doesn't agree with it. Because it put one group over, clustered all those points together, and I can look at the plot and say, that's not a very good choice. It tried to make 2 in here. Really, it should have made 2 in there, right? And it put 0.4, 0.6 down in its own cluster. So that's good in some sense. So I'd say that my k-means got the wrong answer. And probably I need to do something about that. So if I put this plot in my paper, any competent referee is going to say, no, well, that's not what's happening in your data. You're right. It probably has 4 clusters, but that's not the right answer. Question? Okay. Because of that guy down there, I'm going to tell it I have 5 clusters. Because I could just remove that point and tell it I have 4 clusters. But just for fun, I'll tell it that I have 5 clusters, and I kind of hope it's going to get a better answer. There's a problem up here in that these guys are the long and skinny kind, and this is more symmetrical. And so we'll see what I can do. And we're going to kill this. Where's my data? Go back. I'll keep the plot back there. Analyze. We want to do cluster analysis. Recall. Say OK. But this time I want to say that I have 5 clusters because I found that I have an outlier in the data. I shouldn't say it's an outlier. And a point that's different than the other. Maybe my decluttering option isn't good. And then say go. Now I have 2 single points. Interesting. Wait, 3. Oh, this is a completely stupid answer. Guaranteed. I got 1 group there, I got 1 group there, and I got 3 individual points. This cannot be good. Let's see what it did. Go here, make my biplot thing. I don't know what my biplot options are. I can do a 3D biplot. Maybe I should do that. You got to be kidding me. So clearly my k-means is not working very well, right? It says that that's his individual point. For some crazy reason, it's got 2 individual points within this group, and it's still got those guys all wrong. So if you didn't know that hierarchical clustering existed and you're always a k-means person, then you go, oh, this is useless. And you go back to your principal components plot, which shows basically what you want to show about the data. But k-means is definitely not very smart in figuring out what's going on with this data. Remember, it's a computer science approach. So let me say a little bit about a little bit more about k-means. K-means, by the way, is very common. Is it more common than hierarchical clustering? Yeah, it's sort of even. The trouble with k-means is you have to know how many clusters you want. It doesn't make any sense if you don't know, you're just looking for clusters, then k-means is typically not the choice because you have to tell it how many clusters you want. Okay, if I go, we're going to leave this as k-means again. I want to show you something. Here's this little box called single step. This is what the SAS procedure fastclust does. And what fastclust does, and sometimes you need to know what algorithm is being used. What happens if I just click the button and say go? I don't have 3 clusters, but what the heck? Let's see what happens. We failed with 5 clusters. Let's see if we say we only have 3 clusters. It didn't go anywhere. Or maybe I have to click the go button. Didn't I click the go button? Oh, then I made it go somewhere. I get it. We kill that. So what fastclust does and what some software packages do is they guess at the means of the 4 clusters. So I guess I can go over here. Since I can only draw in 2 dimensions, let's suppose that we have clusters. Maybe there's a cluster over here and a cluster over, sort of like our, suppose we actually have 3 clusters in the data, unknown to us. But they're in 27 dimensions, there really are 3 clusters in the data. We just don't know. The k-means, if you choose, in SAS it's called fastclust. I have no idea in SPSS or Stata what it's called, but they always have an option for doing it very quickly. And basically what it does is it picks the 4 point, or in this case the 3 points, so the multivariate mean of the data is right there. The mean of all the data points. It picks the 3 points that are furthest away from that mean and calls them the mean of the 3 clusters. So I need some data here. Which are the 3 points that are furthest away from that multivariate mean? Well, there are 3 of them. Because it's easy for the software to say, oh, the multivariate mean is here, no matter how many dimensions it is. The ones that are furthest away just calculates the distance measure and says the furthest away ones are this one and I don't know, let's see, maybe this one and this one. And it says we're going to make those the 3 means of the clusters initially. Then I'm going to assign each point to its nearest cluster mean. And it goes, well, so everybody gets assigned to their nearest mean. So it's going to converge to this answer. It's going to converge to this group. This will be a group by itself. And this one, where are you going to assign these points? Are they closer to this one or to that one? I don't know what it's going to be. Something. Maybe I'll do that. And it's going to get a wildly stupid answer. And this is what the fast version of k-means does. And I have no idea why anyone in the real world would ever do this. But it's called fast because it's fast. Do not use the default in k-means, or you can get, we got stupid answers even not using the default. But the proper way to do k-means is not any of these ways. And on Thursday, I guess I will talk some more about k-means and how you should do k-means. And maybe I'll see if I can get Jump to actually do the right approach. We'll talk about it on Thursday. And we're done.
Fall just because I'm gonna be so busy with soccer and football.